Okay, so good evening, everyone. Um, so let's start with the class test that I had last week. So, what was the first question? So we have a sequence xn equals sum over items from 0 through n minus 1 sin a plus id.
Sir, how long will today's class continue?
2 hours till 9.
Okay, sir.
Okay, so we needed to show this is like we needed to find a and b. So find a and b, for which the sequence xn is bounded. So how did you solve this one? Anyone?
স্যার
So
এই যে
this,
স্যার এই যে সিরিজটা এটা স্যার মানে এটা মানে সামটা হবে সাইন n d/2 বাই সাইন d/2 ইনটু সাইন টুয়াইস a প্লাস n minus 1 d/2.
yeah, so this is the formula we have to use. I guess it was in your class 11 or 12. And similarly, we have a formula for cos also. I guess it's so sin n d by 2 by sin d by 2 times cos of 2a plus n minus 1 d by 2. Just this sign replaced by cos. Yeah, so that's the crucial formula you need to remember. I guess it can be done without it also, but okay. Then
So we have to show that xn is greater than xn plus 1, right?
here you needed to show it's bounded, so you just have to find an upper bound for each xn. You don't need to show it's monotone or anything like that. That's for the second and third question. Yeah, I mean not the second question, third question.
স্যার এবার যেটা
So
সাইন টুয়াইস a প্লাস n minus 1 d/2 সেটা স্যার লেস দেন অর ইকুয়াল টু 1.
yeah, so it's and similarly both of them are also like constant. So no, this is a constant. So this is less than or equals to 1 and this is less than or equals to 1. And this is a constant.
স্যার কোনটা কনস্ট্যান্ট?
I mean, it doesn't depend on n, sin d by 2. So we just need
Sir, how is sine becoming cos?
no, it's the formula for the sum of uh, n cos ap sequence, like this one, sum over items from 0 through n minus 1 cos of a plus id. That sum is equal to this sin n d by 2 by sin d by 2 times cos of that thing.
Actually, I
Here,
didn't understand the formula you used above.
oh yeah, I didn't derive it. So if you want to derive it, okay, then let's derive
স্যার
it.
স্যার এটার ডেরিভেশনটা স্যার এই ডি মেম্বার সেখান থেকে করা যাবে?
Can you repeat?
স্যার এই সাইন সামেশনের ফর্মুলাটা স্যার ডি মাইনাস থিওরাম দিয়ে করা যাবে?
Yeah, yeah, you can use De Morgan. So, okay, so with De Morgan's theorem, we have like, so it turns into a GP. So think about the sequence. Yn equals to a power iota times e power iota times a plus jd. So j is a natural number. Just a minute. So like we can write xn equals to the imaginary part of sum over I runs from, sorry, not I, j runs from 0 through n minus 1 e power iota times a plus jd. So it's imaginary part of this thing. This is a GP series. If you take e power iota a out of the sum, then wait, it's up till n minus 1, right? Yeah. Iota jd so it's so what's the common ratio? The common ratio is iota j, right? Something like this. Sorry, it's iota d. Okay, so now So from the numerator, we have to collect the imaginary terms. So here we have cos plus. So real, imaginary, or just a minute, it shouldn't look this difficult.
স্যার এটা স্যার এইভাবে না করে যদি আরেকভাবে করা হয়, মানে সামটা ধরে নিলাম স্যার এস, দিয়ে স্যার উভয় পক্ষকে যদি সাইন আলফা সাইন এ প্লাস
Wait. So which sum are you taking as this one, or you are totally using a new method? So
স্যার পুরো
suppose
মানে
x.
হ্যাঁ স্যার
Sin d by 2, right?
হ্যাঁ স্যার সাইন ডি বাই টু দিয়ে গুণ করবো স্যার, টু সাইন ডি বাই টু।
Okay. Yeah, that's the classical method to do it, but I thought I should give the de Moivre a try. But it didn't turn
Sir,
out that way.
shouldn't it be plus sine square d in the denominator? At the last.
Yeah. I don't know why I converted it to minus at the last moment. But still, then it's not that easy to simplify. So we are getting here twice 1 minus cos t, so it's 4 times sine square d by 2. How should I? This one is similarly minus of sine square dy. This is minus of sine. Just a minute then. So we have got cos So now imaginary part, right? Lot of terms are there. One of them is cos A times, so it's minus plus sine square n d by 2 sine d and by 4 sine square d by 2. This one is this is minus 1 times minus, that's plus. So sine A sine n d sine t. Next we have real imaginary. What else can we have? Real imaginary. Yeah, we can take this too. So again it's plus sine 4, sorry, sine squared d by 2 sine squared, shit, n d by 2 Okay, then we have just one more term, that's real imaginary. So
Sir, how is the coefficient 4 of the numerator?
this last term,
Yeah, sir.
yeah, sorry. how to simplify. So we need a sign dy 2 here and n dy 2 up. So we have to get rid of one sin n dy 2 from the first term. So we have to break this one. Sorry. Similarly, this one. So now we can take everywhere you have a sign dy 2, so we can cut one copy. Sorry, cut the wrong copy. Now we have n dy 2. Everywhere we have 4, right? So not here. Okay. Then let's keep the 4 for now. So we have 4 cos A sines just sine n dy 2 and cos dy 2 for sine A sine n dy 2 sorry, we don't have sine n dy 2. It's cos n dy 2 and cos dy 2. Then again for sine A times sine n dy 2. Just a minute, how does the first term has 3? So we had So now we need here a plus n minus 1 d by 2. There are 4 terms.
So shouldn't it be sine n minus 1 d by 2?
So it's sine twice sine c and sine d, sine a into cos b. So it's a plus b by 2 and a minus b by 2, right? As far as I remember.
So sine a plus sine b equals to 2 sine a plus b by 2 into cos a minus b by 2.
Just a minute. I think here we shouldn't have broken down it at this stage. We should have like taken e power iota n d by 2 common. So we have there is an a, so it's plus a. Okay. Along with that we have minus. So this thing is equal to so we can cancel 1 d by 2. Now we have above we have the real parts getting cancelled. Yeah, so the real parts getting cancelled, we only left with the imaginary parts. And d by 2 twice. Similarly in the denominator. What is this thing? Yeah, so we just need the imaginary part here. So it's sine n d by 2. That's what we wanted. So don't break it up into sine and cos at that step. It somehow gets a bit messier. So I need to erase up till here. And and this alternative proved that someone was suggesting it. So now we can see it's that cosine rule. So it's sorry. So it's cos of so now we have a telescope. This is plus, yeah. Just a minute. think I shouldn't be dividing them. So it's d by 2 minus a minus id, so that's plus of twice, sorry, so what's the first one? So 0th, so I can't start from 0 now. Okay, so it's minus d by 2. This is, the first term is plus d by 2. So this one and this one will be left, so that one is cos of a minus d by 2, and what will be the last one? It will be minus cos a plus, I guess, n minus 1 d by 2. Sorry, twice n minus 1 d by 2. So now if we combine them, we have sine, sorry, cos, right? Just a minute. So we will again be getting sine only. How is that? Oh, wait a minute. Why? It's cos. Why are we getting back sine again? What is this term? I'm seriously missing something. I should divide them by 2,
Sir,
of
the
course.
second one should be sine ND or sine N minus 1D.
This term,
No,
I
no,
calculated it
below
wrong.
that.
Yeah, it should be sine ND then. Yeah, but what have I calculated? So it's sine A plus B times sine A minus B. So A got cancelled and twice n minus 1 D. So it's minus 1 minus twice n plus 1. Okay, yeah. So it's ND. Sorry, this one. So it's minus 2ND by 2. So it's sine ND. And here on the left hand side we had 2s sine d by 2. That gives me s equals to, just a minute. Yeah, we need to divide it by 2. Okay, so that was it for the formula. Now, so we needed to show this is bound. We needed to find d and a such that this gets bounded. So xn. So now we already know this is a constant sine d by 2, but this must have a lower bound, so it can't be 0. So sine d by 2 not equals to 0. This implies d by 2 can't be a multiple of pi, not equals to k pi. So that's a condition on d. And any more conditions on a?
স্যার একবার নিচটা দেখান।
This one.
ইয়া স্যার, যান স্যার।
Okay, yeah, so either d not equals to 2k pi and a inside any real number, or if d equals to 2k pi, let's see what happens. So that forces this to be 0. So d is 2k pi, so all of them are sine a basically. So that implies xn equals to, so d equals to 2k pi sum over sine a. So that's simply n times sine a. So this is a constant if we assume a is constant. So this blows up to infinity if a sine a is anything but 0. So this implies sine a is 0, and it implies a is some q pi. So we have either or d equals to 2k pi and a equals to q pi. So these are the two conditions. Next one. So here we had two sequences, xn and yn, and yeah, they also are convergent and they converge to the same limit. So given
Sir, in the above problem, one condition is D is not equals to 2k pi, another.
one condition is d not equals to 2k pi and a is any real number. Another one is d is equals to 2k pi and a is also equals to some q pi for q and natural number, and k is also natural number, because we want the sine a to be to go to 0. I mean to be 0, not go to 0. It has to be 0, or else xn will
So
be
that the
0.
limit exists.
So yeah, then the limit gets to be 0. I mean each xn is 0 for all n. Then
So due to a 0/0 ratio, the limit exists, right, sir?
we just have to show it's bounded. So 0 is obviously bounded by any real number, any positive real number, like suppose 1. So xn is bounded by 1, and here it was bounded by by anything, say in this case. So in this case mod of xn is bounded by 1, and in this case mod of xn is bounded by 1 by c, where c is
But sir,
1
if D
by
equals to 2k
sine
pi,
beta.
then it becomes like xn doesn't exist, right, sir?
No, it exists. You see, here you replace id with I 2k pi. So then this is equals to sine a. So all the terms are sine a. We have n terms. So it's n times sine a.
Yeah, sir.
And yeah, and if sine a is 0, then the all the terms are 0. So xn is 0. Xn is 0 for all n. So it's a constant sequence, constant 0 sequence. Only a constant 0 sequence can make it bounded, else n will make it unbounded. So yeah. So they have the same converging limits xn and yn. We have to show the truthness of the following statement. The first one is the series x sum over xn whether this is true or false, and the second one is power.
So the first one is false.
Yeah, actually both of them are false. So how will you show the first one is false?
Sir, I took the example of like GP series. First one is like half to the power n. Like I considered x to be a series of half to the power n and y to be series of 1/3 to the power n. So when both tends to infinity, they tend to be equals to 0. But they aren't equal, right?
Yeah, so if we take anything like any proper fraction which are not equal, so we can take 2 and 3, so 1 by 2 and 1 by 3. Therefore both the limits are same 0. And then the limit of the partial sums, they are basically GP series. So we have got which is two in case of xn and I runs from 1, right? So this will be 1. Sorry. And here it's 1 by 1 3. So that's 1/3 by 2/3 or 2. Sorry, half. So A is false. Next for B, what's the counter example for B? So now you have to make this power series different. So you can take you can assume the limit of the first left hand side, like you can assume this limit to be some C1 and this limit to be some C2. Like you want to make them C1 and C2, where C1 not equals to C2. So just take the sequence xn equals to nth root of C1 and yn equals to nth root of C2. Therefore, since they are finite and so 1 by n, so it's C1 power limit n tends to infinity 1 by n. C1 power 0 is 1, and similarly C2. But so this is also false. Now the third one. So the third one is that common recursive relation one. We have a recursive sequence defined as xn equals to xn plus 6, square root of 6 plus xn. N is a natural number, and the base case is x1 is square root of 6. We have to find the limit of xn and show that it's converging. So xn converges.
So is the limit 3?
Yeah, the limit will be the lowest upper bound or supremum. Yeah, it's 3. So how is it 3?
So I found out that xn equals to root over 6 plus root over 6 plus root over 6 and so on. I considered it as p. So p is equal to root over 6 plus p. and I solved it. So P comes as -2 or +3. Now -2 is not possible, so P equals to 3.
So -2 or 3, right?
Yeah, but -2 is not possible.
Why is it not possible? Because
Sir,
square root
root
is
over
always
anything
positive.
can't be negative.
Yeah. So
কিন্তু স্যার
but
সিকোয়েন্সের কিন্তু
but
স্যার
this
সিকোয়েন্সের
doesn't. Sorry.
কিন্তু স্যার সিকোয়েন্সের কনভার্জেন্স দেখাতে হবে না, মানে মনোটন কনভার্জেন্স থিওরেম দিয়ে, তবে তো স্যার এটা অ্যাপ্লাই করা
Yeah,
যাবে।
yeah. We have to first show it's converging. Then we can assume that the limit can be p or anything, and then we can try and calculate the limit. So to first, you have to show it is converging. You can use the MCT for that. So you have to show it's monotonic, and obviously it's bounded because. Okay, so to show it's bounded, you can use like you can do this calculation in the rough and like guess the limit to be equal to 3. Now since the limit is 3 and it's monotonically increasing, I guess, because yeah, they are adding up. So it has to be 3 has to be a upper bound. So you can use it as an upper bound and show that this is bounded. So we can use induction to show like so use induction with x1 equals to square root of 6 less than 3 and xn plus 1 square root of 6 plus xn is equal to square root of 6, sorry, not equals, less than or equals to square root of 6 plus 3 equal to 3. So xn plus 1 is less than or equal to 3, assuming xn is less than or equal to 3. Hence all of them are less than or equals to 3. Therefore xn is bounded above. Next, we also need to show
So we can't do this calculation in fair, or we can.
Which one? This
Last
part.
one, sir, where no, sir, last one, where you proved everything is less than 3.
No, you have to do it. You have to show it, right? That's what you have to show. You have to show it's bounded, and you have to show it's monotone. Then only you can assume it has like you can prove its convergence, so you can assume.
So isn't it a sort of back calculation?
No, it's not a back calculation. Like you can like say I want to show everything is less than 3. Like 3 is not important. You can show everything is less than 4 or 5 or like the limit has to be 3. Like you have back calculated these steps, so you know the limit is 3.
Okay, that should be done in rough.
Yeah, yeah. And now you take any number greater than 3 and show that that's an upper bound for the sequence using induction or anything, just inequality. Then, yeah, so it's bounded. And for monotone, um, so what do we have here? What is xn plus 1? It's square root of 6 plus xn, right? So we have to find the inequality between xn and square root of 6 plus xn. So suppose there is some unknown inequality and we squared them. like we know it has to be increasing, right? Yeah, so we know this inequality has to exist. Let us assume this exists, and then we can like change the direction of our steps. So we'll now see where square root of 6 lies. So 6 is greater than 4 and less than 9. The square root of 6 is greater than 2 and less than 3. So it lies in between twice 2 and 3. And now that implies this thing is always negative and this thing is always positive. So the product is negative. So this is always true. So now you can like revert back. You can start with this statement and then end with this one, which implies xn plus 1 is greater than or equals to xn. So it's strictly increasing. Not strictly, at least increasing. So xn is monotone. So by MCT, xn is convergent. Therefore, we can assume that limit xn equals to p or anything, and then we can write p as 6 plus p, where from which you can obtain the quadratic, and solving that you will get get either 2 or 3, 2 or minus 2 or 3. So p equals to minus 2 or 3, and 2 gets cancelled as it's not positive. So our answer is 3. So the last one.
স্যার এটা স্যান্ডউইচ থিওরাম দিয়ে হবে না?
Yeah. Just got notification. Sorry. So here we have a sequence defined in terms of flow functions. So we need to show xn is convergent and find its limit also. So find So we are gonna use the sandwich theorem. So we have to find a suitable upper and lower bound for each term of the sequence, and then send n to infinity, and the lower and upper bound must have the same limit. So natural bound for box x is obviously x minus 1 and x. So just use it. Therefore this thing n squared upon 1 through n box IA. So it's sum over 1 through n. Sorry. Just IA minus n by n squared. This is just sum over. Just a minute. Yeah, I'm back. So yeah, obviously this goes to sum over 1 by a I runs from 1 through n by n squared minus 1 by n. This goes to the same limit because, so what do we have? What is a? A is any real number, yeah. So right, a is any real number. So it's I by n squared times a. I by n squared is strictly less than 1. I mean, as n tends to infinity, this I by n squared tends to 0. So all the terms are 0. So, or you can just sum up using an AP. That should be easier. So it's n into n plus 1 by 2 n squared minus n. So it's equal to a times 1 plus 1 by n, 1 by n. This thing goes to 0, this thing goes to 0. The whole thing tends to a by 2. So both of them tend to a by 2. So this one has to tend to a by 2 also. The sandwich theorem. So that was the end of our class test. So let's start with continuity now. So how do we define a function as continuous? So there are lots of notions of continuity. One involving sequences and their subsequences. Another one involving neighborhoods and open intervals. Third one is there in topology. We will not get into that. We will just discuss the two notions of continuity. So definition. So f is a function from an open interval u in R to R. And we say f is continuous at x equals to a in u such that if and only if for all epsilon greater than 0 there exists delta epsilon positive such that the distance between such that for all y inside.
Sir, is it U belongs to R open?
I mean, U is open. U is an open, not belongs to actually. Sorry. So U is a subset of R which is open. Is that okay?
Yes, sir.
So for all for all y inside, I mean, yeah, you can write it in as inside also, but that will be difficult to understand. So such that for all y in u, such that mod of y minus a is less than delta epsilon implies, I mean, this selection of u implies mod of f of a minus f of y is less than epsilon. So that's the full definition of continuity of a function defined on an open interval over R at a point x equals to a. So this is definition number 1. Then we have another definition that's so like the other definition is okay. So similarly we have f defined an open interval in R. It's an R to R function, U to R function, sorry. We say f is continuous at x equals to a in U if and only if here. So we have for all sequences xn in U such that limit n tends to infinity xn is some L and L is inside U. Yeah, it has to be inside U. I guess it's not necessary. Okay, it just has to converge to some real number. And not and implies this sequence limit n tends to infinity f of xn. This sequence must converge to that same limit equals to f of limit n tends to infinity xn equals to f of L. Okay, so I hope like to get an idea of what this definition is saying. So suppose like a function is there which maps an open interval U to some range subset of R. So f must be f is continuous at a point A if you take any neighborhood point of A in the domain set, and suppose f maps A to some set. Oh, sorry. Here I choose it to be L. It's not L. It's at limit point A. Okay. Yeah. So f maps A to some point f of A. So if you take any point in the neighborhood of A, it has to go to some neighborhood of f of A. If that happens, f is called continuous in A. the third definition that I was talking about. So definition 3. So definition 3 we have hmm. So we have a map F from U to R. So F is continuous at x equals to A in U if and only if there exists open set, not open set, open set, yeah, open set, yeah. Okay. So okay, yeah. So it's like if and only if for all v open inside R. So we take a open set in R containing x. So V is a neighborhood of f of A. Sorry, not x, A. So if V is an open subset of R containing A, f of A, sorry, f of A, then F inverse V defined as the set of all x's such that f of x is inside V. So this set F inverse V is this F inverse V is inside U and is open. So that's the third definition. So this does exactly what the diagram tells us to do. We take a point A, and if we want to show it's continuous at A, we look at the point where it's mapped to by F. It's f of A, and now we can, if we take any open set V containing A, which is also called the neighborhood around A, and then look at the inverse. So look at some inverse of this set, this open set containing f of A. That inverse has to contain, has to be totally contained in U, that's the domain, and has to be open. It's obvious that it will contain A because f of A is obviously inside V since it's a definition of V. So it will contain A, and this inverse will contain A and will be an open set in the domain space. So that's what the third definition says. Second definition says that if you take any convergent sequence which converges to A, call it xn, and then you consider and if you transform the sequence with f, then you get a new sequence, suppose yn, and that sequence also eventually converges to f of A. If that happens, then f is continuous at A. And the first definition is the simplest one. So you just need a delta epsilon for the corresponding epsilon, such that whenever y is pretty close to A, f of A is also pretty close to y. Sorry. So now we have to show all the three definitions are equivalent. We can show it now, or so. equivalence of def 1, 2, 3 of continuity. So can you guess which two definitions will be easiest to conclude equivalent? We actually need more results to show the second definition is equivalent to third definition. Like the properties of open set, that's any sequence which has okay. Okay, so let's start with one implies two or two implies one. So how to proceed? So take any sequence xn. So takes xn convergent. Xn converges to a, the point where you want to show the limit. So now we need to show the sequence f of xn. The sequence f of xn, this is also convergent and converges to f of a, assuming f is continuous. So we are in this one. 1 implies 2. So we have assumed 1, that is f is continuous. And now we have to show so we have to show that 2 happens. That sequence is also convergent. So just a minute. Yeah. Okay. So first we to show 2 we need to find like let's assume the contrary. So assume the contrary. So we have to show this to show f of xn goes to f of a. F of xn doesn't converge to f of a. Then what can happen? So Yeah, so xn converges to a, and f of n doesn't converge to a. What does it suggest? Like if we take, this is suppose f of a, and for all epsilon uh, there is some n greater than, like what is the definition of convergence? So y is convergent. So let me do it with f of xn. So f of xn is convergent to f of a if and only if for all epsilon greater than 0 there exists capital N inside natural numbers, such that for all small n greater than capital N, mod of f of xn minus f of a is less than epsilon. So how do we negate this statement? So negation of this statement, if and only if there exists epsilon, so for all changes to there exists epsilon positive, such that for all n in natural numbers, and for all n in natural numbers, for all this goes to there exists n greater than n, which implies mod of f of xn minus f of a is greater than epsilon. So however close we get, I mean, yeah. So however long we wait, however much larger the n is, there will be some epsilon such that this epsilon, this difference is greater than that epsilon. Yeah, so with this we can try to construct a sequence or a subsequence of f of xn which indeed converges to f of a. So how do we do that? So for each n, so we will define a sequence as follows. For each n in capital, I mean in natural number, there exists epsilon, right? So just a minute. So first we fix an epsilon positive. So by definition one, there exists a delta epsilon. There exists a delta epsilon such that for all that y mod y minus a less than delta epsilon, this implies mod fy minus fa less than epsilon. So now if wait and we know that we have a sequence xn that converges to this a. So since this converges, we can take we can say there exists some capital N1 such that for all n greater than capital N1, mod of xn minus a is less than that this delta epsilon. Since xn converges to a. So after n1, everything just gets closer to becomes less than delta epsilon, and we know if something is less than delta epsilon, this thing should happen. So therefore, these two implies f of xn should be yeah less than epsilon, since mod of xn minus a is less than delta epsilon. So that's the according to definition 1. Oh, sorry, we have already used definition 1. So we just found our n1 such that everything greater than n1, this thing is less than epsilon. Therefore, fxn is convergent to f of a from this. So 1 proves 2. I mean 1 implies 2. Now the other way around, 2 implies 1. For 2 implies 1, now we have the sequence definition. So for all xn which goes to a, uh, f of xn goes to f of a. We have assumed this. Now we have to show there exists that delta epsilon for all epsilon. So So here again we will use the proof by contradiction method. So assume the contrary, that f of xn doesn't converge to f of a. No, not yeah. I mean, so like f of a is not a limit point according to definition 1. We have assumed this. So if it's not a limit point, then there exists a sequence, suppose like en inside u, such that en tends to a, but f of en doesn't tend to f of a. Therefore, for all epsilon greater than 0, for all delta greater than 0, uh, there exists y such that the mod of y minus a less than delta implies mod of f of x minus, sorry, f of y minus f of a. This is greater than epsilon.
Sir, can you say what's the first line? Assume the contrary, that FA is not a limit.
Fa is not the
Limit point after
limit
that.
point.
After that.
According to definition 1.
Okay.
Yeah, so now since just a minute. Yeah, so to generate such a subsequence e, we can choose delta equals to 1, 1 half, 1/3, like any sequence that converts to 0. 1/4 converts to 0. So you take a sequence delta and converging to 0. Suppose you take the harmonic sequence, and then since we know that for each of these deltas there exists a y such that y is closer to a, y is the difference, yeah, y is more close to a than delta, and still this is greater than epsilon. So for this, for all n in natural number, there exists yn such that mod of yn minus a is less than delta n, but mod of f of yn minus f of a, this is greater than epsilon for that fixed epsilon. Yeah, this epsilon. Therefore, so we got the sequence f of yn. This sequence, it doesn't converge to f of a. Yeah. And what are these delta n? These delta n are 1 by n, right? And we already have the definition 2, but according to definition 2, yn tends to a. This must imply f of yn tend to f of a. Yet here f of yn is not tending to f of a, right? So that's a contradiction. Yeah, that's a contradiction. So that proves 2 implies 1. So 1 implies 2 and 2 implies 1, therefore 1 and 2 are equivalent. No, why 2 and 3 are equivalent? I will show it next week. So next week we'll show 2 implies 3 and 3 implies 1. Okay. So that's it. That's where I stopped the class today, and I will try to post the solution of the previous class test by next week. I don't know if I will success. Okay, whatever. So see you next week.